Hello all, let's discuss the last part of section 1.5. Still we are in 1.5. That was a long section. Again, the last part of section 1.5, still we are dealing with solving quadratic equations, but this time the last method, the fourth method of solving quadratic equations, and this method is using quadratic formula. Solving equations using quadratic formula. Before that, I introduce to you the quadratic formula, and I know most of you remember this formula. It's really, really famous formula. I'll do here a proof for you from where this formula comes in. But let me remind you, let me tell you that don't worry about the proof. You are not required in this level to learn the proof. But at least I want to show you from where this formula comes in and why the greatest mathematician, his name was Muhammad from Khwarazm, uh, he actually created this formula, correct? And he is the founder of Algebra somehow. Why he created, what was the reason, and how he created this formula, this quadratic formula. I'll show you a proof here. Just at the end, you will end up with the formula. I'll box the formula for you. You are required to just memorize the formula and use the formula to solve quadratic equation, not the proof. But it's good to know why formula and from where this formula comes in. If you remember at the beginning of talking about 1.5, when I introduced to you the quadratic equations, I put a general form for you. Any equation that's in the form of ax squared plus bx plus c equals 0, we call it a quadratic formula. The first method was factoring, correct? The second method was using square root property to solve these equations. The third method was completing a square. Let's use completing a square on this general form. Let's do completing a square on this general form, on this form, and see what's happening and continue. There is no number. It's all A, B, C, X, right? But let's do completing a square on this general form. The first step is to move C to the other side, which is the constant term. Then I'll rewrite ax squared plus bx equals negative c. Now I'll add half of b, square it, add it to the both sides of the equation. I told you when you do completing a square, you take the coefficient of x, you divide it by 2, and you square it, and you add to your both sides of equations. I'm sorry, even before this, one more step. Now, second step, you see the coefficient of x squared is not 1. Let me change it to 1 first, then I'll add. What I do here, I'll divide everything by a to change the coefficient of x squared to 1. Here, x squared plus b over a x equals negative c over a. Now half of b over a. The other day I told you when you have a fraction and you want to take the half of it, it means multiply the denominator by 2. Correct? Now square it and add it to your equation to both sides. Then x squared plus b over a x plus b over 2a squared equals negative c over a plus b over 2a squared. Left side of the equation, I will write it as a one factor, correct? Parentheses, x sine from the second term, which is plus the square root of b over 2a, all square is b over 2a, and square, equals, I will simplify the right side, negative c over a plus b squared over 4a squared, correct? Let's add these two fractions on the right side. To add these two fractions to the right side, I need a common denominator. It means I have to multiply c over a with another 4a to get a common denominator. Let me show you the process. I'll rewrite this step. I will write one more step. X plus b over 2a all squared equals negative c over a. What I do here, I will multiply the top and bottom by 4a to get a common denominator, right? Plus b squared over 4a squared. Now you see denominators are the same. I can write it as a one fraction. Then x plus b over 2a all squared equals negative 4ac. If I write it in a nice way, right? Over plus b squared over 4a squared. Now, you want to solve this equation using the square root property method. I'll take the square root from both sides. It means I will write a square root of x plus b over 2a all square equals plus minus square root of, let's write the top in a nice way in order. I will put the positive term first, then the negative term, right? B squared minus 4ac over 4a squared. Here, square with cancels out with the square root, then x plus b over 2a equals plus minus, denominator has a square root. The square root of 4a squared is 2a. But in the top, because it's two terms, it's a binomial, you have to keep it under the square root. Square root of b squared minus 4ac. Now, solving this equation for x, I will subtract negative b over 2a from both sides. I will subtract it from here, and I'll subtract from this side also. These two cancels out. Then x equals negative b over 2a plus minus my second fraction, which is the square root of b squared minus 4ac over 2a. You see, you have denominators are the same, and you can write as a one fraction and one single fraction, correct? Then you can write x equals one big fraction, negative b plus minus square root of b squared minus 4ac over 2a. This last step, we call this proof or this step or this quadratic formula. Quadratic formula, actually, you see, it's the shortcut for completing a square. I know I was a student and I'm teaching mathematics for many years. Students, mainly, they don't like to use the completing a square method to solve a quadratic equation because it's too long, because it's easy to do a mistake. Then what they do, instead of using the completing a square method, they created the quadratic formula. In this formula, A, B, and C are numbers, correct? When they give you a quadratic equation, any equation, just plug in A, B, C in your formula, and at the end, you always get your answer for quadratic equation. Any quadratic equation can be solved by this formula. If you forgot about your factoring, okay, don't use the factoring method, use the quadratic formula. If you don't know how to use the square root property, but you have to simplify first the equation, then you can use the quadratic formula. And even those quadratic equations that you cannot factor, you can solve it by quadratic formula, correct? That was a proof. And again, you are not required to learn the proof. For those of you that you are interested in, you may learn how I did. I just did completing a square on the general form of quadratic equations, and I end up with quadratic formula. But just memorize this last part, and you can solve any quadratic equation. Now, I'll do like 2 or 3 examples for you using the quadratic formula, and I will solve few quadratic equations for you. Let's start with example number 1. Let me copy a problem from your book. 3x squared minus 2x minus 4 equals 0. Those of you that you are really new with this topic, the first thing to do is identify A, B, and C. That is the main and important part. How much is A? A means the coefficient of x squared. A is 3. How much is B? B is the coefficient of x, which is -2. How much is C? C is your constant term, which is -4. This is your A, this is your B, and this is your C. Do not forget the sign. Oh, C is 4. No, C is not 4. C is -4. B is 2. No, B is not 2. B is -2. Be careful with the sign, because if you kind of be careless and don't care about the sign, your answer is wrong. Oh, sir, I used all the quadratic formula correctly, but my answer was wrong. Why? I lost point. Because you didn't focus on the sign. Your answer is different. That answer is not the solution of your equation, correct? Focus on the sign of your terms, correct? Now, step 2, write down your formula. I'm recommending you for each problem, please write down the formula, because by writing the formula a few times, automatically you can memorize it. Don't try to read and memorize x equals negative b plus minus square root of b square minus 4ac over 2a. Don't memorize it this way, read and read and read. You cannot do that. But if you write few times, believe me, it goes automatically. Automatically, you can memorize it, correct? My formula was negative b plus minus square root of b square minus 4ac over what? 2a. Now, just plug in the numbers in your formula. Be careful with the sign again. X equals negative b. You see, you have one negative from your formula. Keep it. This is the place that most of the students does the mistake. They say negative b, then they copy negative 2 here. There is another negative from formula. It means negative, negative 2. Correct? Plus minus square root of b square. How much is my b? Negative 2. You see, I'm using parentheses because I want to square also the negative. Minus 4 from the formula AC. A is 3 and C is negative 4. All over 2 times A, which is 2 times 3. Now, slowly, carefully, do the operation and simplify. X equals negative, negative 2, double negative becomes positive. It means 2 plus minus b squared, negative 2 squared. Negative 2 squared gives you positive 4. Negative times negative gives you positive. 4 times 3 is 12. 12 times 4 is 48. Over 2 times 3 is 6. Now, simplify a little bit more. X equals 2 plus minus a square root of 4 plus 48 gives you 52. Over 6. The tricky part here is this is your answer, but is 52. Can you write a square root of 52? Can you simplify this square root? If you remember in intermediate algebra, when your professor, your teacher taught you radicals, you can simplify a radical if it's possible as a radical times a number, correct? To do that, you have to find which numbers can be multiplied to gives you 54, and at least one of them should has the square root. Let's try. Do we have such a number? I will start dividing by 2. 52 dividing by 2. 2 times 26 times. 2 times 26 gives you 52. Again, divide by 2 gives you 13. Here, look, 13 is a prime number. You have to divide by 13. 2 times 2 gives you 4. And 4 times 13 gives you 52. What I do, here I will write x equals 2 plus minus square root of 4 times 13 over 6. Or you can write x equals 2 plus minus square root of 4 is 2 it goes outside, and 13 stays inside the radical over 6. Now you can factor out 2 and simplify with denominator, or you can write as a partial fractions and simplify. It means do this. X equals 2 over 6 plus minus 2 radical 13 over 6. 1 time, 3 times, 1 time, 3 times. I can simplify. Then X equals 1/3 plus minus square root of 13 over 6 to solution for the quadratic equation. If you try to solve this equation by factoring, you can't. Because you see here the radical is involved. It means you cannot factor. Correct? This method is the easiest, fastest method to use to solve quadratic equations. Correct? Maybe I'll do another example also for you. Example 2. 8x squared plus 2x minus 1 equals 0. My first step is a equals a, b equals 2, and c equals -1. I want to make this list always because I'll show you why. And I'll explain something else also here for you. 8x squared plus 2x equals 1. If they give you the equation in this form, remember, first move all the terms to one side, to the left side, make it equal to 0. Why? Because if you want to copy here, how much is A? A is equal 8. How much is B? B is equal 2. How much is C? C is equal 1. If you do this, you are wrong. C is not 1. If you move it to this side, C becomes -1. Remember this. If you have a term on the other side, move everything to one side first. Make one side 0. Then read your ABC, how much is A, how much is B, how much is C, find it out, correct? Now, second step, formula, x equals -b plus minus square root of b squared minus 4ac over to a. Then x equals -b, how much is b? 2, it means -2. Plus minus a square root of 2 squared minus 4 times a, which is 8, times c, which is -1, over 2 times 8 to a. Simplify. X equals -2 plus minus a square root of 4 plus negative times negative gives you positive, 4 times 8, 32. Over 60. X equals -2 plus minus a square root of 36 over 16. Oh, 36 has a perfect square root. We are lucky. X equals -2 plus minus a square root of 36 is 6 over 16. Now, to solution. The first one, -2 plus 6 over 16, which gives you 4 over 16, which gives you 1 over 4. The second solution, -2 minus 6 over 16, which gives you -8 over 16, which gives you -1/2 to solution of the quadratic equation. Hopefully by these two examples, it's nothing else that I do a lot of examples for you to explain to you to learn. It's just adding, subtracting, squaring, taking the square root of a number. It's just numbers. You're dealing with numbers. I think 2 examples will be enough. Just watch this video and practice with your homework. You will be good to go. In this part, after you learn the quadratic formula, let's talk about, and this is the last part of the lecture, types of solutions of quadratic equations. What does it mean? When you solve a quadratic equation, which kind of solution you have at the end? Sometimes, like this example, you have 2 different solutions, but both of them are real numbers. Sometimes, when you solve a quadratic equation, you end up with 1 solution, or you end up with 2 solutions which they are both of them are the same. Sometimes when you solve a quadratic equation, you end up with 2 imaginary, or I can say 2 complex number solution. That means you deal with I, correct? We call these types of the solutions of quadratic equations. How to know which kind of solution I will end up with? Look, your quadratic formula was x equals negative b plus minus, I'll change the color here. No, even not now. Now I'll change the color. B squared minus 4ac over 2a. Even before solving a quadratic equation, if you see the red part under the radical, which is b squared minus 4ac, if you find b squared minus 4ac for any given quadratic formula, it explains to you which type of solution you have for your quadratic equation. How? You have to remember this 3 possibilities actually. If your b squared minus 4ac becomes greater than 0, it means if b squared minus 4ac, which, let me also introduce the name for you, we call it discriminant. If your discriminant is a positive number, in this case, you have 2 unequal real solution. 2 or reasons unequal, or you can use different. 2 unequal real solution. Possibility number 2. If b squared minus 4ac, your discriminant, is equal to 0, In this case, one real solution. Your quadratic equation will have one real solution. And last, if b squared minus 4ac becomes less than 0, if it's a negative number, in this case, no real solution, but you have two imaginary solutions. Two imaginary solutions. Let's practice with few examples to see. We are not solving here the quadratic equations. If on the test day, I'm asking you, I'll give you a quadratic equation and say, which type of solution this quadratic equation have? You don't need to solve to know which type. Just use discriminant and see one of these possibilities and answer the question. Correct? Example number 1. We are looking for the types of solution. 3x squared plus 4x minus 5. Find the type of solutions for this quadratic equation. Correct? What I do, I'll use my discriminant. My discriminant is b squared minus 4ac. Even I will not write equal or less or greater. Just plug in the numbers here and see which kind of number you get. Your a is 3, your b is 4, your c is negative 5. Then 4 squared minus 4 times a, which is 3, times c, which is negative 5. 4 squared gives you 16. Negative times negative gives you positive. 4 times 3 is 12. 12 times 5 is 16. Which this number gives you 72, right? If you add these, 76, if you add these two numbers. Is 76 is greater than 0, equal to 0, or less than 0? Of course, this number is greater than 0, right? It means your discriminant is greater than 0. Now check. When the discriminant was greater than 0, you have two unequal real solution. Or simple, you can write two real solution. This equation definitely has two real solutions. Even if you want to solve it, just instead of doing all this calculation again, use 76 under the radical. And you will see you will have two real solutions. Example number 2. Nine x squared minus 6x plus 1 equals 0. I want to see which type of solutions this equation has. Discriminant, b squared minus 4ac, we call it discriminant. Plug in the numbers, b squared, it means negative 6 squared. Minus 4 times a, 9 times c, 1. Negative 6 squared gives you positive 36. Minus 4 times 9, 36. What is 36 minus 36? 0. Here, again, check. When b squared minus 4ac becomes 0, I have one real solution. Here, your discriminant is 0, correct? Then you can write one real solution. This equation has one real solution. Very easy, correct? Let's do one more example. Example 3. 3x squared minus 8x plus 7 equals 0. To know which type of solution this equation has, I will write my discriminant, b squared minus 4ac. Even, let me tell you, in some books, they use this sign, delta. Delta equals b squared minus 4ac. In some books, I never seen this sign to be used for discriminant here in the books in the United States. But before, in other countries, I saw some books that they are using delta as a discriminant to represent the discriminant, correct? It doesn't matter if you use this sign or not. I just told you, in some books, they are using this sign, this triangle, which we call it delta, as a symbol for discriminant, correct? But right now, let's go back to the problem. B squared, negative 8 squared, minus 4 times A, 3 times C, 7. Negative 8 squared gives you 64. Minus 4 times 3 gives you 12. 12 times 7, 84. Correct? 64 minus 84 gives you negative 20. Is negative 20 is greater than 0, or it's definitely it's not 0, or less than 0? You see, negative 20 is less than 0. If your discriminant is less than 0, then you have two imaginary solutions. It means when you solve this problem, definitely you get an I in your answer, correct? Which we call it two imaginary solutions. This was all about section 1.5. Really, really a long section. I'll stop the lecture here and see you all in section 1.6.